My dear students, in today's class, let us see some more examples under solenoidal and irrotational vectors. Here we have an example. Show that vector f is equal to y plus z into I plus x plus z into j plus x plus y into k is irrotational. Also find a scalar function phi such that vector f is equal to del phi. Here, to solve this problem, we have to show that the given vector is an irrotational vector. We know that the condition for irrotational vector, that is curl f must be equal to 0. What is that? The condition for irrotational vector is curl f must be equal to 0. If it satisfies, then we can say that the given vector f is an irrotational vector. Now we have to consider this curl f. Let us consider curl f and let us verify whether it will be 0 or not. If it is equal to 0 vector, then we can say that the vector is irrotational vector. Otherwise, it is not irrotational vector. Now let us consider this curl f. Curl f is equal to del cross f. This we know, right? The definition of curl is del cross f. And we know the cross product. How we have to write the cross product? It is nothing but the determinant of ijk being the first row elements and the second row elements being the elements of this del. Second row elements being the elements of this del and third row elements being the elements of this vector f. See, ijk will be common and elements of second row is what? Del. Del is what? Del is nothing but, see, del is nothing but dou phi by dou x, dou phi by dou y, dou phi by dou z, isn't it? See, since it is phi, I have written phi. If it is not there, just del. Del is written as dou by dou x I cap plus dou by dou y j cap plus dou by dou z k cap. So only the coefficients of this ijk we have to write here, that is dou by dou x, dou by dou y, dou by dou z. See, these will be always same. For three-dimensional coordinate system, this never changes. Dou by dou x, dou by dou y, dou by dou z. Okay. Now the next one is the third row elements being the elements of this vector f. See, in this vector f, what is given here? Vector f, it is again a three-dimensional coordinate system. ijk, three-dimensional coordinate system, it is given. Now I component term y plus z, j component term x plus z, k component term x plus y. Now we have written all the terms in this determinant. Now let us solve this determinant. You know how to solve the determinant, right? See how to solve the determinant. This is plus and it is minus and it is plus. See, for the first term I into, if you just leave the first row and first column, then dou by dou y of this minus dou by dou z of this. Isn't it? See, dou by dou y of this means it is nothing but the differentiate partially with respect to y. Differentiate this partially with respect to y. What's the differentiation of this with respect to y? This one is 0 and this one is 1. So 0 plus 1 is 1. So that I have here 1 minus this into this dou by dou z of this means this one differentiate with respect to z. Partially differentiate this with respect to z. So 0 plus 1 is 1. 1 minus 1. See, this 1 minus this is 1. Now minus j into, again, yes, first row, second column. If you leave first row, second column, dou by dou x of this x plus y. Differentiate this with respect to x. X differentiation is 1, y differentiation is 0. So when you differentiate this with respect to x partially, so it will be 1 plus 0 is 1. 1 minus, differentiate this with respect to z. So differentiate, see, dou by dou z of y plus z. Differentiate this with respect to z. Z differentiation is 1, y differentiation is 0. That is 0 plus 1 is 1. 1 minus 1. Now similarly for the next element k, see, leave the first row and the third column. So it is dou by dou x of this with respect to x means partially with respect to x means 1. 1 plus 0. 1 minus this into this, differentiate partially with respect to y. So partially with respect to y means 1 plus 0 is 1. See, 1. Okay. Now 1 minus 1 is what? 0. 1 minus 1 is 0. 1 minus 1 is 0. Now it is 0i minus 0j plus 0k is nothing but 0 vector. See what we have to get? We have to get 0 vector. Yes, we got 0 vector here, isn't it? So we can say that vector f, given vector f is irrotational vector, or it is nothing but vector f is conservative force field also. It is also called, if this happens, then we can say that the given vector f is conservative force field. The half of the question we solved. Now another part is what? We have to find a scalar function phi such that del phi is equal to vector f. We have to find a scalar function such that vector f is equal to del phi. See, we have to find a scalar function phi, unique function phi we have to find. See, in this case, this condition will help us. See, consider del phi is equal to vector f. See, what is the meaning of del? Del is nothing but dou phi by dou x I plus dou phi by dou y j plus dou phi by dou z k is equal to vector f. The given vector f, whatever it is, I have written as it is. Now, equate the coefficients of ijk components. Equate the coefficients of ijk components. I component, equate the coefficient of I component. That is dou phi by dou x is equal to y plus z. Similarly, dou phi by dou y is equal to x plus z. Dou phi by dou z is equal to x plus y. Now, we have to solve these three terms separately. Now, I will explain these three terms how you have to simplify this. Okay. For the first time, dou phi by dou x is equal to y plus z. Now how you solve this problem? See, here the derivative is a partial derivative. Here the derivative is a partial derivative. See, to eliminate this partial derivative, what you have to do? You have to integrate anyway. You have to integrate this with respect to what you have to integrate. You have to integrate this with respect to x. Integrate with respect to x. Now here, when you are integrating with respect to x, since it is a partial derivative, this phi is a function of three variables actually. It is function of x, y, z. But you are integrating only with respect to x. The other variables which is present here, these two you have to treat it as constant. So it is treating the other variables y and z as constant. Okay. So when you are integrating this, what you will get in the left hand side? See, this will be eliminated. This partial derivative notation will be eliminated. You will be remaining with phi is equal to y integration with respect to x will be what? Y as it is into x plus z integration with respect to x. Z integration with respect to x is what? Z as it is into x plus when you are integrating, you will be writing integration constant, right? That integration constant here, it will be a function of the variables which is treated as constant, that is y comma z. This one we will find it later. Okay. Now this is what the solution of this first term. Now similarly we have this next one, that is dou phi by dou y is equal to x plus z. Here again phi is a function of what and what and what? Phi is a function of x comma y comma z. See, here we are integrating this with respect to the y variable. So this notation will be eliminated and we will be remaining this phi, that is phi is equal to x integration with respect to y. X integration with respect to y is xy plus z integration with respect to y is zy plus integration constant we write now when we are integrating, integration constant, that is a function of. Since I have used f here, I will use g, one more function. I will construct with one more function, that is g of the variables which is treated as constant. Here which are the variables treated as constant? Treating which are the constant? Here y is the variable which we are integrating with. See, these two are the variables which is treating constant, x and z. Now here g is a function of x and z. The function of z, x and z is written as g of x comma z. Now again this one we will find it later. Okay. Now again the third function. Which is the third function? See, the third function is dou phi by dou z is equal to x plus y. Now again here it is a function of what and what and what? Function of x comma y comma z. Here with respect to what I have to integrate? I have to integrate this with respect to z and treating the other variables constant. Treating which are the other variables among these three when you are integrating this with respect to z. See, these are the variables which you are treating constant. Treating x and y as constant, isn't it? Now when you are integrating this notation will be eliminated. You will be remaining with phi. Phi is equal to x integration with respect to z is xz plus y integration with respect to z is yz plus when you are integrating, some integration constant will be written. That integration constant will be a function, right? It is not a constant, it is a function. See, what is that function? That function is, see, here I have used f, g. Now I will use h here, h of the variables x comma y. Now this x comma y we will find it later. Okay. Now we have to have a unique scalar function phi is equal to something. Actually here how many phis are there? This is one phi, equation 1, this is second phi, equation 2, and this is third phi, equation 3. We need to have a unique phi. By using these three phis we will be constructing a unique phi function, unique scalar function. Now I will tell you how to construct that unique scalar function. Okay. See, here we have this function f of, see, let us choose these functions f of y comma z, g of x comma z and h of x comma y. Let us choose this f comma g comma h. Okay. Now what is that f? F is a function of y comma z. Now you have to choose a function y comma function which is purely a function of y and z. So in that term x must not be present. X must not be present. It is a function of purely y and z. So you have to choose the terms which are functions of only y and z. Means x must not be present. Purely a function of y and z. See, x is there, no, it cannot be. X is there, it cannot be. Now x is there, no, it cannot be. See, x is not there. Only z and y. Only y and z. So this can be taken. This can be taken. Yz can be taken. This is from equation 2. From 2. Okay. Now again keep on searching like that. See, yz again. yz. This is from equation 3 we have. See, this is x is present in this term, so it cannot be written. Now, see, function of yz is zy and yz. Among these two, see, product rule is a commutative. See, it can be written as yz and zy, both are same. Now, among these two, any one can be taken. Any one term can be taken. Any one term can be taken for this f of y comma z. Okay, similarly, search for g of x comma z. G of x comma z. See, what is g of x comma z? You have to search for the terms which are purely a function of x comma x and z. X and z. See, x and z, only these two terms are there. Y is not there. See, zx, which is from 1, from equation 1. Now, x comma z is not there in this equation. Xz is there. Xz is there. That is from equation 3. Now, zx and xz both are same. Any one you can take here also. Any one term you can take for this g of x comma z. Similarly, go for h of x comma y. So, you have to search for a term which is purely a function of x and y. Which is purely a function of x and y. See, x and y, that is yx from 1, from equation 1. Now, again, in this term, xy is there. Xy is there from equation 2. From equation 2. In this equation, you don't have any xy terms. Isn't it purely a function of xy? You don't have. Now, only two things, that is xy and yx. See, here both are same again. So, any one term you can take for this h of x comma y. Now, we have to construct a function, scalar function phi, by using all these three equations. See, but you should not repeat any term twice. Okay, if it is repeat, you can take it only once. See, I'll explain that. See, xy or yx, both are same, right? See, I will write this xy as yx. I will write this xy as yx. See, zx I will take, since it is different from this, zx I will take, plus function of y and z. So, see, function of y comma z is what function of y and z is. Any one from this, see, zy or yz, I will take yz. Okay. Now, other terms, you keep on writing the other terms. If it is different, you can write. If it is same, you can leave the terms. See, xy again. In this second equation, xy. Xy already written. You don't need to write this. See, zy or yz already written. You don't need to write this. You can leave it. Now, g of x comma z. What is g of x comma z? We have chosen, right? G of x comma z is what? Zx or xz. See, zx or xz already written here. So, you don't need to write again g of x comma z. Okay. Now, keep on searching the terms. If it is different, write it. Otherwise, leave it. Okay. Now, xz already there. Yz already there. H of x comma y. H of x comma y is xy or yx. It is already there. So, this is the unique scalar function that you have to construct for the given vector field. Now, we'll have the next example. It will be similar to this only. If you want, you can see this. I have written it neatly. Since it is not understood, if I don't explain, that's why I explained with a new sheet. See, this is the problem we have. See, this is the problem we had given with. Now, the steps, and here we have integrated with x with respect to x, with respect to y, with respect to z, and I explained these three equation 1, 2, 3. Explained this, and we have to choose the arbitrary functions fgh such that we obtain a unique expression for phi. See, this one also explained, and I told you how to construct this scalar function. Now, we'll go for the next example. It is similar to this example. Yes, we have this example. If vector f is equal to x plus y plus az into I plus bx plus 2y minus z into j plus x plus cy plus 2z into k. Here you have to find the constants a, b, c such that curl f is equal to 0 vector, and then you have to find the scalar function phi such that vector f is equal to del phi. Here also you have to find, here vector f is given. See, for this vector f, you have to find the constants a, b, c. You have to find the constants ABC. See, for this problem, you have to find the constants ABC. Here, they have not asked you to find the irrotational or a conservative force field. Whether the given function is a conservative force field or an irrotational vector, they are not telling about it. But they told you to find the constants ABC. To find the constants ABC, they have given a data. What is that data? They told that curl vector f is equal to 0 vector. This will happen, seems. So, if it happens, then you can find the constants a, b, c. See, they are telling us this will happen. So, this will happen means what is that? Curl f is equal to 0 vector. See, curl f is nothing but del cross f. We know this definition, del cross f. You know the definition of cross product also. See, it is nothing but the determinant of first row being the elements of ijk, second row being the elements of dou by dou x, dou by dou y, dou by dou z being the elements of this del, and the third row being the elements of this vector f, that is x plus y plus az, bx plus 2y minus z, and x plus cy plus 2z. Okay. Now you know how to solve this determinant. I into, you can leave the first element, first row and first column, and I into dou by dou y of this element minus dou by dou z of this element. Dou by dou y of this element means differentiate partially with respect to y. So this one will be 0, this one will be 0. Y differentiation is 1. You will be remaining with C. Minus, differentiate this with respect to z partially. So minus 1. So minus into minus is plus 1. Differentiate this with respect to x. X differentiation is 1. All other terms are 0. 1. 1 minus. Differentiate this with respect to z. So differentiation of z is 1. So you will be remaining with a. 1 minus a plus k into. Here differentiate this with respect to x. So x differentiation is 1. So it will be b. B into 1 is b. B. This 2 will be 0. B minus. Differentiate this with respect to y. Y differentiation is 1. This 2 will be 0. 1. B minus 1. You will be remaining with this. See what they told? They told that curl f will become 0 it seems, is equal to 0. See left hand side, let us have this 0 vector. Curl f is equal to what they have given. They given that it is 0 vector. It is 0 vector it seems. 0 vector can be written as what? 0i plus 0j plus 0k, isn't it? See, that is written here. This I have taken here. This is equal to 0i plus 0j plus 0k. Now again equate the components of ijk. Both the sides in LHS and RHS. Equate the components of I, J, K. See what you will get here. C plus 1 is equal to 0. Isn't it? And J component minus of, negative here it is, minus of 1 minus A is equal to 0. And B minus 1 is equal to 0. Now from these three equations you can find the values of A, B, C. It is not a matter for you. You will understand this. Well, now we'll go for the next one. That is, see, we found the values of A, B, C. Now we have to find the unique scalar function phi, such that vector f is equal to del phi, isn't it? See how we have found in the earlier problem. In the same way we are going to find the phi, that is a scalar function. Okay, now let us consider this vector f is equal to del phi. Vector f is equal to del phi. What is vector f? This is a given vector, given vector as it is I have taken here, is equal to del phi. What is the meaning of del phi? Del phi is nothing but what? Dou phi by dou x I cap, dou phi by dou y j cap plus dou phi by dou z k cap. This is equal to this. Again equate the components of I j k. So when you equate the components of I j k, it is dou phi by dou x is equal to this I component, whatever it is, coefficient, that dou phi by dou y is equal to this. I have written here. Dou phi by dou z is equal to x plus cy plus 2z, that I have taken here. Now let us solve these three equations. You know how to solve these three equations. Anyway, I will solve this for you. Yes, see in this problem again, what is that? See, I have dou phi by dou x is equal to x plus y plus az I have, isn't it? Now I have to eliminate this partial derivative so that I will integrate this with respect to x and treating the other variables constant. Which are the other variables? X. See, phi is a function of x, y, z. See here we are integrating with respect to x. The other variables are y and z. So treating y and z are constants. Y and z are constants. Now let me integrate this. So if I integrate this, I will be remaining with phi is equal to x integration with respect to x is x square by 2 plus y integration with respect to x is yx plus az into x. Az with respect to x is azx plus the constant is a function here, function of y and z, y comma z. Okay, this is equation number 1. Now dou phi by, second equation, dou phi by dou y is equal to bx plus 2y minus z. Now what I have to do here? I have to integrate this with respect to y and treating x and z are constants. X and z are constants. So what I will be remaining with? I will be remaining with phi is equal to, integrating with respect to y, it bx phi plus 2 into y integration is 2y integration, 2 into y square divided by 2 minus z integration with respect to y is zy plus integration constant is here, it is a function, right? So I am using g of x comma z, isn't it? This is equation number 2. Now we'll go for the next equation, one more equation, third equation, that is I will show you this again. Third equation is what? Dou phi by dou z is equal to x plus cy plus 2z. Now I have to eliminate this derivative. So integrate with respect to z and treating which are the variables here? See, other than x, other than z, you have x and y, right? Treating x and y as constant. So when you are treating x and y are constant, it is when you are integrating this, so it will be phi is equal to, this will be eliminated. Phi is equal to x integration with respect to z is xz plus cy integration with respect to z is cyz plus 2z square integration with respect to z is 2z square divided by 2 plus integration constant, here it is a function of h, here I will take the denotation h of what? X comma y, isn't it? Now these two will 2 and 2 will be cancelled each other. Here also 2 and 2 will be cancelled each other, isn't it? Here 2 is not there. Okay, leave it, not a problem. Now from these three equations we have to construct a unique scalar function phi, isn't it? See, 1 2 3, by using these three equations I have to construct a unique scalar function phi. This I have to construct. To construct this, let us choose FGH. Let us choose FGH. See, what is f? F is a function of y comma z. Now which are the terms which are purely a function of yz? Choose. Okay, now yz, right? See, yz is not there, x is there, x is there, x is there. No, it cannot be. Now x is there, only y is there. See, it must be a purely a function of y and z. Here y is there, z is not there, so it cannot be written. It is not the term, because the term must be a purely a function of y and z. Here z is not there, so zy is there. Minus zy. Minus zy is a purely a function of y and z. Now that's all, isn't it? And in the third equation, cyz. This is from 2. This is from 2. From second equation. Now cyz. C is constant, right? Cyz. This is from third equation. C is equal to what? This value we already found it, right? C value I found it. It is minus 1 into yz. It is nothing but again minus zy only. Now see, other than these two, we don't have any other term which is purely a function of yz. Okay, now this next one, g is a function of what? G is a function of xz. Now let us choose a term which is purely a function of xz. Okay, now in the first equation, xz, no, xz, y is present. It is not a term which is purely a function of xz, because z is not there. Xz is in the first equation, I got it. See, axz. Okay, now in the second equation, axz, y is there? No, it is not. Xz, no, y is there. In the third equation, xz is xz. See, this one from 1, this one from 1, and the next one from third equation. Xz is the third equation. Again, a value. What is the value of a? We already found it. A value is what? A is equal to 1. A is equal to 1. So when you put it, so a is equal to 1. Again it is 1 into zx. That is zx only. 1 into zx, that is zx only. See, zx, xz both are same. Any one among these two you can choose. Here minus zy, minus yz. Any one among these two you can choose. Okay. Okay. Now come for the next one, that is h of x comma what it is? H of, here it is, h of x comma y. Now you have to choose a term which is purely a function of x and y. See, in the first equation, x and y is yx from 1. This is not a purely a function of xy. Only x is there. Here z is there. No, it cannot be. Now second equation. In the second equation, bxy from 2. See, y is there. Only y is there. Here z is there. So it cannot be. Now in the third equation, you don't have any other term which is purely a function of xy. Now these are the only two terms. Now what is the value of b? B value is plus 1. Now 1. When you put a b is equal to 1, you will get xy only again in this one, isn't it? Now among these two, you can choose any one because both are same, isn't it? Now let us construct the scalar function phi, which is unique. Okay, see, from the first equation, 1 2 3, from these three equations, let us choose the terms. Okay, if it is different I will write, if it is same I can leave it. Okay, now in the first equation, see, in the first equation, phi is equal to what? X square by 2. See, it is different. X square by 2 plus yx I can write, plus a value is what? A is equal to 1. So it is zx. A is equal to 1. Zx. I can write this. Okay. Plus fyz. What is fyz? Fyz is minus zy. Minus zy. Now come to the, see, all the terms we have written in the first equation. In the second equation, if it is different I will write. If it is same I can leave that term. Okay. Now bxy. What is b? B is nothing but 1 plus 1. So it is plus 1. Bxy. Xy is there. Yx or xy both are same. I can leave this term. Okay. Now y square plus y square. I just left this because b is equal to 1. Okay, b is equal to 1, xy is there already, yx, xy both are same. See, y square is different, I have written here. Now minus yz is there. That's why I can leave this term. Now g of x comma z, what is g of x comma z which I have chosen? xz already there. So I have written all the terms which are different from equation 1 and 2. Now come to the equation 3. In equation 3, xz already there. Now cyz, c value is minus 1. C is equal to minus 1. So C is equal to minus 1 means what? Y minus yz only. Minus yz. Minus yz we have written here. Okay. Plus z square. It is different now. That's why I am writing z square. Plus h of x comma y. What is h of x comma y? xy again. Isn't it? xy already there. See, I have written all the terms which are different in all these three equations, that is 1, 2 and 3. Now this is a unique scalar function that is constructed. Okay. So that is x square divided by 2 plus y square plus z square plus xy plus xz minus zy. This is the unique scalar function that we have constructed for the given vector field. I will show you the solution for this question from the beginning. See, this was the question given. For this question I have explained how to find the values ABC values we got here. You can see in this sheet of paper. Next we have to find the scalar function. To construct this unique scalar function, we are given with vector f is equal to del phi. See, by using that we found this equation and we have equated ijk components. So we got these three equations and we have integrated this with respect to x and integrated with respect to x, y, z separately. So we got three equations again. From those three equations we have constructed a unique scalar function phi. See, this is the function we got. This only I explained. Thank you.